So my 4G Wi-Fi modem sucks. Hopefully at the end of this 30 minutes, some of you will agree with that statement. My name's Silas. I haven't always been a douchebag exec. I had a background in security operations. My career's been about 10 years, had some pretty interesting roles, and it's great to be here. Like everyone else here, the views expressed are my own. My employers have their own. I'm sure they have legal writing that says that. And the vulnerabilities presented today, I disclosed to the manufacturer via Telstra around about 10 months ago. All good? All right. So the background. Basically at work one day, bit of a quiet period, and I had my MF91, and I thought, oh, it's a good chance to give it a bit of a shakedown in the security space. So I loaded up a couple of my tools, I started fuzzing, and the thing fell in a screaming heap on the ground. So I picked up the phone, called my mate OJ, who has the same device, and I'm like, hey, Juice, if you type this in the URL bar, tell me what happens. He's like, okay, type it in. He said, yeah, screaming mess. I thought, okay, well, this probably deserves some closer inspection. So the device itself, this is it. You go into a Telstra shop or an Optus shop, you'll see a Huawei version or a Sierra Wireless version, or this is ZTE. They're quite popular. It's got 802.111 BGN network capability for all your devices, 5 simultaneous client connections. It's got a little embedded web server called Go Ahead Web's version 1.2. Supports WEP, WPA, WPA2. And as of this morning at least, on ZTE Australia's site, it's still listed as a current product. So it's still in circulation. The tools I used, pretty much Burp Suite. For those who haven't used Burp Suite, it's the duck's nuts when it comes to web application pen testing. It's got a whole ton of functions. It's a free version. I'd suggest you check it out. You can muck around with your requests, your get and post requests and parameters and that kind of thing. And I just use wget. You can swap out wget for Perl, Python, Linux, curl, pretty much anything where you can control get and post requests. And that's what when I actually wrote the proof of concept code, I just did it in bash and just used wget to do the heavy lifting. So. Important to note, we're not attacking 4G comms in this presentation. There's no actual services enabled either on the external interface of the device, so they got that right, which is awesome. But Steve's going to be talking about GSM and those kind of things coming up next, so if you're interested in that, I'd stick around. You can think of the attacks as basically taking a run at a home ADSL modem connection, essentially. It's essentially the same kind of device, but that's where we'll be looking today. The method, really simple. Load up Burp Suite, throw some requests at it, log into the device, check out all the parameters, all the functions that are running, start mucking around with parameters and see what you get back. It's not advanced, it's not special. It's the standard systematic testing of a web application. I put a slide here on the disclosure because when I accepted the request to talk here, I put a tweet up saying, I'm really looking forward to coming to Crikey to talk. And someone sort of shot back, well, geez, I hope you've disclosed this responsibly. And it's kind of it's a contentious issue in the community. So I just wanted to list the comms that happened between myself and the vendor over 232 days, which is quite a long time. Typically in the community, 100 days is kind of acceptable for between disclosing and then expecting a patch or a fix to be out. I gave them 232 days, and it's important that you, I think at least, that you disclose responsibly, but you do it firmly. So vendors aren't sort of having a laugh. They tell you that, we're fixing this. It's coming up, and then all of a sudden, nothing. You get a black hole. So it was 232 days between the provision of the proof of concept exploit code and then a blog post that I did. I think that's fair. Okay, let's smack one around. So, we'll start with the credentials. Password is required, obviously, to manage the device. It's very typical of any kind of sort of Soho router. And those passwords typically need to be protected, obviously, not dumped in plain text on the HTML of the landing page when you rock up. So what's highlighted here, you see lines 20 and 127. Line 20 is the wireless key. That's just the default wireless key to join that wireless network that it's sharing. And then line 127 is actually the admin password for the login. So you don't have to remember it, the admin password. You just right-click view source and get it. Just kind of convenient, I suppose. Does anyone not know how to right-click view source? I'll teach you later. It's really easy, but I'm not going to demo that right now. Authentication. So the device uses cookies, again, a fairly standard method of tracking authenticated sessions. The core of the cookie for the MF91 is a value that is labelled MF91 Telstra Luck Num, which is basically a lucky number. It's a number that's between 9 and 13 digits. That's what I've observed anyway in my dealings with the device. And when you log in correctly with the password, you get a lovely cookie back with that value, so that lets you dance around all the different pages and all the different settings without having to re-authenticate. So that's it right there for some reference, I guess. That's what it looks like. Problem is, you can actually grab this value without being authenticated. So using just a tool again like wget, you can just grab it and roll your own cookie. So not really, unfortunate, that's what I put the word there, unfortunately, because it is kind of unfortunate. Okay, so we'll have a look at what that looks like. Okay, just make sure I'm connected here. Okay, sweet. Right, so this is the landing page for the Telstra's version of the ZTE. As you can see, I'm at login.asp. If I change that to index.asp, which is the landing page post-authentication, I get myself a 301 redirect back to login because I don't have a cookie. I don't have my magic cookie. So that's cool. Don't need it because if I type in forms, sorry, command equals. There's my lucky num. Wicked. Okay, so I'll copy that, and what I'm going to do is, there's any number of ways to roll your own cookies. I'm just going to use Cookies Manager, so I'm just going to go crack in a new cookie here, call it the correct name, which is MF91 underscore Telstra underscore luck num. Content, which is that value. The host, which is the IP address of the MF91, and document root / save that. Okay, if we go back. Okay, at the login screen now, if I, come on, demo gods, index.asp. There we go, login. Unfortunate is the term. I'll just log out there. Okay, so that's not a great start. Let's get rid of all that junk. Okay. Right, the wireless network key. So there's a setting on the device where you can set the wireless network key to actually rotate and just sort of display and rotate on the LCD screen itself. I guess if you want to share the device, you don't have to, you just tell them go view source on the main page and get the wireless key there. If you want it for esoteric appeal on the LCD screen, you can do, you can set that setting. On the main page, there's regularly get requests generated to update like a little picture of the device itself, so you know what you see on the screen you can actually see on the website itself. And that calls this value xe_display password. You can see here just the the burp capture comes quite regularly. That RD value next to it is, I think it's a positioning value, but anyway. Appending unexpected characters to this value results in unexpected behaviour. So let's have a look at some of that unexpected behaviour. What we want to do there, what I might do, there it is. So everyone can see. Can everyone see that? Is that big enough? Yeah? Okay. Just a tad small. Wake up. All right. Okay. So I'm going to use wget. Again, obviously I'm not authenticated here. Now, go quiet so I don't see the. Oh, we don't need that. Okay. Oops. Quiet. Okay, I can throw this at it all day. Nothing happens. But, oops. Yeah, if I throw in semicolon now, let's make sure that light doesn't go off. I'll throw a semicolon in. Bang. Totes secure. All right. Also not so great. Okay, we've done that one. Protected functions, another good one. So any kind of change to a core function of the device, like the password, administrator password, SSID, if you want to turn AP isolation on or off, firewall rules, that kind of thing. They should obviously, industry standard, be secured against unauthorized changes. But the MF91 doesn't actually check whether incoming GET or POST requests have that awesome, valid, magic number that they so carefully protect. And it's inconsistent. The only place I've actually found it to check is at login time, but you've seen how good that is. The failure to check these requests against a known authenticated cookie means that an attacker on that same network segment can pretty much do whatever they want to the device. So let's do that. I'll start with what I might do is I'll start with we'll just go there. We'll just do it for the fun. We'll view the page source and we'll find the admin password, which there it is. It's set at password. So that means I should be able to just go password login. Yep, that's cool. So that's the password. Finally, I go log out. Because it's a post request, we use post data. We just say password equals hi CrikeyCon. Quiet. Okay, let's refresh that. And view page source. There you go. Not great. I'll just test that, make sure. Hi CrikeyCon. Not good. All right. So that's one that's not protected. Another one. Do we get just scripted this? Slash. one more post data there. Equals pwned. Let's see that. Okay. So as you can see, I've changed the SSID and you'll see that I lose network connectivity. And I have to reconnect now to, yeah, there you go. So it's totally brought down the wireless interface on the device, as you would expect when changing SSIDs. And we've got time for one more, yeah. Couldn't fit the T in there for some reason, don't know why. There you go. Let's make sure you're alive. Boom. Factory reset. Unauthenticated. So, yeah, it's unfortunate is the term. There you go. That's it booting up to its default profile there. Right. Okay. Kind of ahead of time here, but that was fun anyway, hey? In summary, mobile devices, particularly modern embedded devices, they contain a ton of vulnerabilities. You think about it, you think manufacturers like Huawei, ZTE, and Sierra Wireless, they're all competing in the same market. They've got to get their product out first. It's got to get into the stores quicker. So the first thing that they start stripping out is costs to make sure that a large telecommunications company will, happily procure their product. The next thing that goes is proper security testing, a proper UAT environment, and any kind of infrastructure in place to rapidly deploy updates. So this is not going to stop. It's going to continue, which is not great. You don't need sophisticated tools to find these kind of bugs and vulnerabilities. It's just a systematic approach to penetration testing, and I've just shown you there. It really was not a big deal to find these kinds of things, and making sure you're just thorough and checking will result in bugs bubbling to the surface. And it's not just these things. It's pretty much everything. Your smart TVs, fridges, car systems, the Internet of Things. Wade.
Shells for everyone.
Yeah, exactly. There is a ton of places that these kind of bugs reside in. The scary ones are the things that control life or death, like hospital systems, life support, that kind of thing. But there's tons out there to play with if you're interested. Research ethically and disclose responsibly, but again, firmly. Don't let them take the piss. It's important. We have a responsibility in the community to disclose responsibly, but manufacturers also have a responsibility when they become aware of a bug, they should fix it, and in a timely manner.